Did Jupiter almost become a second sun? Jupiter is the biggest planet in the solar system, but that almost makes it sound normal. Jupiter is mostly made from hydrogen and helium, the same basic ingredients as the Sun. It gives off more heat than it receives, it has no solid surface, and it has so many moons that it almost looks like the center of its own tiny solar system. So naturally, people sometimes call Jupiter a failed star. But is that actually true? At first, the idea doesn't sound completely ridiculous. Jupiter really does share something important with the Sun. It's not a rocky world like Earth or Mars, it's not a solid planet with mountains, oceans, deserts, or a surface you could stand on. Jupiter is mostly hydrogen and helium, the two lightest elements in the universe, and the same basic ingredients that make up stars. That already makes it feel different. Jupiter is a giant sphere of gas and pressure. The deeper you go, the less familiar everything becomes. The clouds turn into thicker layers, the pressure rises, the temperature climbs, and hydrogen starts behaving in ways we never see on Earth. Somewhere far below the visible clouds, Jupiter becomes less like a place you could visit and more like an enormous natural machine. That is part of why the failed star idea has survived, because Jupiter doesn't look like Earth's bigger cousin. It looks like something built from the same cosmic material as the Sun, but sent down a completely different path. Both the Sun and Jupiter formed from the same ancient cloud of gas and dust. One became the star at the center of the solar system, the other became the giant planet orbiting it. And that's where the question starts feeling uncomfortable. Because if Jupiter is made from star-like material, why did one object become the Sun while the other became a planet? That question becomes even harder to ignore when you realize Jupiter is not just made from star-like material. It also gives off its own heat, not just reflected sunlight from the Sun. And that's where Jupiter starts to feel genuinely suspicious. Because in the simple version, stars are the objects that create energy, and planets are the objects that borrow it. The Sun shines, Earth reflects, Mars reflects, Saturn reflects. That's the basic picture most of us carry around. But Jupiter doesn't fit neatly into that picture. Jupiter gives off more heat than it receives from the Sun. At first, that sounds almost star-like. A giant ball of hydrogen and helium, warmer inside than it should be, leaking energy into space. But this is where the difference matters. Jupiter is not producing the heat through nuclear fusion. It's not burning hydrogen into helium. It's not a hidden little sun wrapped in clouds. Most of that heat is ancient. It's leftover energy from Jupiter's formation, from the time when the solar system was still young, violent, and full of material crashing together. And because Jupiter is so massive, gravity is still slowly squeezing it, releasing even more energy over enormous stretches of time. So Jupiter is not shining like a star, it's cooling like a giant world that has never fully let go of its birth. And that makes the failed star idea even more tempting. Because now Jupiter is not only made from the same basic ingredients as the Sun, it also has internal heat, it has gravity, it has pressure, it has everything that sounds like it should matter. So why did it never ignite? The answer is simple but brutal. Having the right ingredients is not enough. A star is not a star because it's made of hydrogen. Jupiter has hydrogen. A star is not a star because it's hot inside. Jupiter is hot inside. A star is not even a star just because it's massive. Jupiter is massive, at least compared to every other planet in the solar system. What makes a star is what happens deep in its core. Gravity has to squeeze the center so violently that hydrogen atoms are forced together. When that happens, nuclear fusion begins. Hydrogen becomes helium and an enormous amount of energy is released. That is what the Sun is doing right now. It's not burning like fire. There is no oxygen feeding flames. The Sun shines because its core is under such extreme pressure and temperature that fusion can keep going. Second after second, year after year, for billions of years. Jupiter, however, never reached that point. It has hydrogen, it has helium, it has internal heat, it has crushing pressure, but it doesn't have mass to push its core over the edge. And this is where the phrase failed star starts to fall apart. Because Jupiter didn't almost ignite and then somehow fail at the last moment. It was missing the one thing that matters most: mass. A lot of it. And when we say Jupiter doesn't have enough mass, we are not talking about a small difference. This is not Jupiter being slightly too light. This is not a nearly star that missed its chance by a tiny amount. To become a true star, Jupiter would need roughly 80 times more mass than it has now. 80 Jupiters. That is the part that changes the whole story. Because when people hear failed star, it sounds like Jupiter was close, like the solar system almost had two suns, but Jupiter fell just short at the final step. But that's not really what happened. Jupiter was never one lucky accident away from becoming a star. It was never sitting there in the early solar system, almost ready to ignite, waiting for one last push. It was enormous for a planet, but tiny compared to a star. And that's the difference. Compared to Earth, Jupiter is a monster. Compared to the Sun, Jupiter is a lightweight wearing a very confident jacket. The Sun contains more than 99% of all the mass in the solar system. Jupiter may dominate the planets, but next to the Sun, it's still so small. So the failed star idea is powerful, but it's almost misleading. Jupiter didn't fail to become a star because something went wrong. It failed because it never had enough material to begin with. Or more honestly, it did not fail at all. It became exactly what its mass allowed it to become. A giant planet. Not a failed star, not a failed sun. A world massive enough to feel suspicious, but nowhere near massive enough to cross the line. So if Jupiter is not really a failed star, then what is it? This is where the term brown dwarfs come in. Brown dwarfs are some of the strangest objects in space because they sit in the uncomfortable gap between planets and stars. They are not normal planets, but they are not proper stars either. They form with far more mass than Jupiter, but not enough mass to become true hydrogen-burning stars like the Sun. Their cores can get hot and dense enough for some limited fusion, especially with a heavier form of hydrogen called deuterium. But they can't keep ordinary hydrogen fusion going for billions of years. This is why brown dwarfs are sometimes called failed stars. They are much closer to what people imagine when they use that phrase. Objects that had some of the conditions needed to become stars, but never became massive enough to properly switch on. Jupiter is not in that category. It's far too small. And that matters because it means Jupiter is not sitting right on the border between planet and star. It's not one of those cosmic halfway objects glowing faintly in the darkness because it's almost made it. Jupiter is firmly a planet. A giant planet, yes. A strange planet, yes. But still a planet. And yet the comparison refuses to disappear, because even after we remove the failed star label, Jupiter still doesn't feel normal. It's not a failed star, but it's not just another world quietly orbiting the Sun. It is something else, the most extreme planet in the solar system, and the one that comes closest to making the word planet feel too small. And you can see that most clearly when you look at what surrounds it. Jupiter doesn't just have moons, it has an entire system. Io is covered in active volcanoes, constantly reshaped by the gravitational pull of Jupiter and the other moons around it. Europa is wrapped in ice, but beneath that ice there may be deep global ocean, making it one of the most interesting places in the solar system when it comes to the search for life. Ganymede is so large it's bigger than Mercury. If it orbited the Sun directly, we would probably call it a planet without thinking twice. And Callisto is ancient, battered, and covered in scars from the early solar system. These are not just little rocks drifting around a big planet. They are worlds, and together they make Jupiter feel less like a single object and more like the center of its own small kingdom. That is what makes Jupiter so strange. It didn't become a star, but it became powerful enough to shape everything around it. Its gravity controls the moons. Its magnetic field creates a brutal radiation environment. Its storms can last for centuries. Even its presence helped shape the architecture of the solar system itself, influencing where material moved, what survived, and how the inner planets were protected or threatened during the chaotic early years. So no, Jupiter is not a solar system's second sun, but it's the closest thing we have to a second center. A giant world with its own family of moons, its own internal heat, its own violent weather, and its own enormous influence. And that's why the label failed star is so hard to kill. Not because it's technically right, but because Jupiter genuinely feels like it should belong to a larger category than a planet. So, is Jupiter a failed star? No, not really. It has the ingredients that makes the question tempting. Hydrogen, helium, internal heat, enormous gravity, a whole system of moons around it, but it never had enough mass to become a star. Jupiter would have needed dozens of times more material before its core could ever reach the conditions needed for sustained fusion. So the failed star label is not really accurate, but it is understandable because Jupiter is not strange in a small way. It's the biggest planet in the solar system, it gives off its own heat, it has no normal surface, it shapes the worlds around it, and compared to every other planet we know, it feels like something different. Not a failed star, not a hidden star, but a giant planet so extreme that people had to invent a more dramatic name for it. And maybe that's the real answer. Jupiter didn't fail to become a star, it succeeded at becoming the strangest planet in the solar system. And if you're still here, thank you. If you enjoyed the video, consider leaving a like and subscribing. I know everyone says it, but it does really help my channel. You'll also find few astronomy and space related books linked in the description if you would like to support the channel further, along with more content at spaceopedia.co.uk. Thank you for watching, and as always, keep looking up.